This video isn't really about debugging per se, it's more about teaching you some ways to improve and optimize your code, to make your code more efficient, to find bottlenecks in your code and parts of your code that are slow and inefficient and can be improved. In particular, I'm going to focus on two concepts in Matlab. One is the tick-tock function pair, and you can probably already guess why it's called tick-tock. And then I will show you this really awesome tool called Profile Viewer. It's really great. It will blow your mind and really take your programming skills to the next level. All right, I'm sure you're pretty excited. Let's switch to Matlab and begin. So the function pair tick-tock works pretty much how you would expect it to work. So you write tick, and then, so the function tick, notice I'm not providing any inputs and I'm not getting any outputs. There are ways to get inputs and outputs. I'll show you that later. And then you write some code, and then you write talk. And then Matlab will return the output of talk will be the amount of time that has elapsed since tick. Okay, so here the code inside tick and talk is not terribly interesting. I'm using the pause function to pause for 1 second. So we start the clock, we wait for a second, and we stop the clock. And then Matlab tells us that the elapsed time, so this is the output of the talk function, the elapsed time is 1 second and a little bit of change. Basically, all of this that's left over, this is how much time it took for Matlab to initialize this and compute the talk function. So now watch what I can do. I can hit talk again, and now it says elapsed time is 24 seconds. So it's still going back to this first time that I called talk. So as long as I keep running talk without rerunning tick, then we still get the total elapsed time since the last time we ran tick. So now this is like I'm resetting the clock here. And now it's only been 3 seconds since I last pressed this one. Okay, so here I want to show you that for some functions, Matlab will need a little bit of time to initialize the function on first use, the first time you call a function in a Matlab session. So for example, here is how many data points is this? 100,000 data points. And I'm taking its FFT, its Fourier transform, and let's see how long this takes. Okay, so that took 0.02 seconds. So that seems pretty fast. But now if I run this code again, notice that now it was an order of magnitude faster. So it was actually much faster the second time. And that wasn't a weird fluke. That was just the extra overhead time that Matlab took to initialize the FFT method. So if I keep running this over and over again, you'll see it's generally around 1 millisecond or up to 3 milliseconds, a couple of milliseconds, but certainly a lot faster than the 25 milliseconds it took the first time around. Okay, so that's just a little bit of tip for timing code. So one of the things that you can do with the tick-tock function pair is experiment with different ways of coding the same result. So that's what we're going to do now. Let me set this to be 300 first. So what I'm going to do is, so I set this parameter to be 300, and here I'm creating a matrix, and in a for loop I just set the ith row and ith column to be equal to I. So basically this is just populating the diagonal of this matrix. Now notice we get a little warning message. Matlab is saying that the variable changes size in every loop iteration. Consider pre-allocating for speed. Now I've shown you previously that you can initialize variables to increase the efficiency of Matlab code. So let's try that here. So I'm going to do tick and then all of this code here to generate that matrix, and then the output of talk. Now here I'm requesting an output, and that's going to be the first element of a variable t. Okay, so that was actually really fast. Notice, when we when we request an output from talk, we don't get that automatic message. But I can type t here and see that this loop took, so all the code between tick and talk took 20 milliseconds. So it's pretty fast. Now let's try it again. Here I am, this code is identical. Well, variable name is different, but otherwise it's identical code. But here I'm initializing the matrix, and that's going to go into T2. Okay, also very fast. And here we have no loop whatsoever. I'm using the function diag. I haven't introduced you to this function, but essentially you can use diag and input a vector, so 1, 2, 3, and MATLAB will return a square matrix with the elements of this vector on the diagonal. So this is just a way to create the same matrix that we have here, but without having a loop. And now we do this. Okay, also quite fast. So now let's make a bar plot. And what we are comparing is the computation times. So here you have the 3 different versions of the code. And remember, the result is identical. We get exactly the same matrix for all these 3 different methods. So the question is, which is the fastest? Which is the most efficient? Now, you look at it's clear that diag function is the winner, and it's also very clear that initializing the matrix gives a big improvement. Now you might be looking at this and say, well, come on, Mike, this doesn't really matter. Who cares if we need to wait 20 milliseconds? I am patient enough to wait 20 milliseconds. But wait, this is for a relatively small matrix of 300. So now I'm going to change this to 3000, and I'm going to press Control Enter to run all of the code in this cell again. So now it says busy down here, and I can type a number here, and I don't actually care about the number 7. I'm just doing this to show you that MATLAB was stuck inside this computation. So now we have this matrix. It's 3000 by 3000. Not even such a huge matrix, but quite a bit bigger than 300 by 300. And now it's the difference between almost 9 seconds, and here you literally cannot even see the bars. They are so incredibly tiny, you do not see the bars. So it turns out that with initializing the matrix, we get this down to 4.1 milliseconds, and using the diag function, it's 4.5 milliseconds. Okay, so this is illustrating a way to make your code more efficient and become a better programmer by using tick and talk function pairs to time different computation possibilities. All right, so that's all I'm going to say about tick and talk. Now I want to introduce you to the MATLAB Profiler. The MATLAB Profiler is a tool that MATLAB offers that will analyze your code as you run it, and it will diagnose your code. It will tell you how much time your computer spent running each particular line of code, each loop, each subfunction, and so on. And this is going to help you identify bottlenecks in your code. Now there's one kind of mildly annoying feature, which is that Profile wants to run on a separate file. So if you have code that you want to run Profile on, if it's the entire script, then it's no problem. You write Profile on, or you type Profile on, you run that script or function, and then you type Profile Viewer. Now, if you only want to profile a little piece of code, so for example, let's say you just want to profile this cell of code here, you don't want to profile the entire script, then what you have to do is copy all of this code in question, put it into a separate file. So that's what I did here. I call it temp script. And notice this is not a function, it's just a script. And then I'm going to run profile on, and then temp script, so we run that function, and then profile viewer. So let's run these things and see what happens. Oops, I'm not in the right folder. This needs to be here. Okay, now we're in the right folder where this temp script lives. So now it's running that script, and it takes a while because I intentionally made that script inefficient to illustrate the profiler to you. Okay, so now we get this nice little window opening up. This is called the Profiler Viewer. And let's see what this looks like. So this tells us the function name. So we ran this function called temp script. It was called once, so not surprising, I just called it once. And the total time was around 19 seconds. Okay, so now this is a hyperlink. I'm going to click on this link here. That takes me to the analysis of this file. Now there's a lot of things you can look at in here. The first thing that MATLAB shows you after some basic information is line numbers that take a particularly long amount of time. So this particular line, and I can show you that line in the script in a moment, this particular line was called 100,000 times, and it took 15 1/3 seconds. So in fact, 80%, 4/5 of the time that MATLAB was running this code, it spent on just this line. And then here is, another line. So this is 13% of the total runtime was spent on this line. So now you can click on these hyperlinks. That's actually just going to move the cursor down here. So I just want to show you this. This gives you some warnings, some messages. The variable ls1 appears to change in size on every loop iteration. This is a matrix that is not initialized, and I'm going to show you that in a moment. In fact, we're going to make a huge speed improvement by initializing this matrix. Okay, so now we can scroll down. This shows you the entire code right here, all the code, and it tells you exactly, well, okay, not exactly, but to within 1 millisecond of precision, how much time was spent on each line of code. And then the highlights are showing you different things. So the number of times that these lines were called. So these two lines of code, or this line in particular, was called 100,000 times because we have 1,000 here and inside this loop, and then 100 here inside this loop over here. And so here's the total computation time. So I'm going to change this here. Color, highlight code according to, I'm going to do time. So now that reloads this window. And now we can see this is the offending line. This took a lot of time. This one, I hope you can see that this is also highlighted. This line is also highlighted in like a light pinkish color. Okay, so now what I'm going to do is click on this hyperlink here. That will take me in the code to exactly that line that is that we were looking at in the profiler. Now, this is literally exactly the example that I just showed you with tick and talk. So what I'm going to do is initialize this. So this is going to be zeros of j. Okay, and then we don't actually need to clear that variable anymore. So now I change this code a little bit. I'm going to save this code and then rerun the profiler. Now remember that first time I ran the profiler, it was around 19 seconds. It was just under 19 seconds. So by initializing, we've already reduced it to 3.7 seconds. So now we can go in here. And in fact, that line of code still takes, quite a bit of time, but now that's 3%. Remember, that was 80% of the total runtime. Now it's not even 3%. Pretty neat. And of course, once we made that line of code much more efficient, now Matlab is showing us other bottlenecks, other lines of code that are taking a relatively long period of time. So this is really interesting and really impactful for your coding skills. You can look through this profiler and see if it's possible to reduce computation time further. In fact, it's possible here because this line is redundant. We could just transpose this first matrix, but that doesn't matter. This code doesn't do anything. It's just some random code that I wrote just to be able to look at this profiler. Now, the very last thing I want to say is just a warning. If all of the actual code that we want to run is in this script here, but I copied it over to this script in order to run the profiler on a separate file. So if you're doing that, you're making all the changes in this code. Don't forget, warning, red lights flashing, sirens going. Don't forget all of the changes you make in this temp file, you're going to have to copy them back into the main file. Otherwise, you did all this work for nothing. What if you delete this file because you think, oh, this is a temp script, I don't need this anymore. So just be mindful of that. So in this video, I introduced you to two methods in Matlab for being able to test and optimize your code and looking out for inefficiencies or places in your code where you can make improvements. So that is the tick-tock function pair to test for the elapsed amount of time, and the Matlab profiler, which will examine and diagnose your script and try to tell you or give you information about which lines of code take the most amount of time, which get the most function calls, and so on.